Good afternoon, everyone. Thank you all for joining us today. We will be doing the HFST webinar series, measuring HFST safety and functional performance over time. I'd like to introduce everyone to Adam Weiser. He is the chair of the Quarterly Topics Task Force Committee, and he worked to put this event together. Adam?
Great. Thank you, Rita. And thank you, everyone, for joining our webinar today. I'm going to go ahead and introduce our moderator, David Merritt. But before I do that, I just want to put a plug in for anyone that is interested in other HFST related webinar topics. If you have certain topics that you'd like us to try to put together a webinar for, please let Rita know. You can let us know through the chat pod, or you can email Rita after the webinar is over. So thank you very much for that. So let me go ahead and introduce David Merritt. David Merritt is a project director with the TransTech Group of Austin, Texas, a firm which specializes in pavement research and engineering. One of his areas of specialty is high friction surface treatments, and since 2008, he has been involved with numerous FHWA and industry efforts to evaluate and implement HFST. He received his bachelor's degree from Northern Arizona University and master's degree from the University of Texas at Austin. He's a registered professional engineer in Kansas, Minnesota, Missouri, and Texas, and currently serves as secretary for the ATSA HFST Council. I'm going to go ahead and turn it over to Dave.
All right, thank you, Adam, and thank you all for being here on the webinar today. An exciting topic to present by our speakers today. I'd heard a little bit about some of the work that's been done with high friction surface treatments at intersections in British Columbia several years ago, and then was pleased this year at TRB to see a paper presented on it by our two speakers that'll be presenting during the webinar. So Joy and Mohammed have been gracious to present their work for us. And without further ado, I'm going to go ahead and introduce our two speakers and let them take it from there. Joy Sengupta is a principal highway safety engineer with the British Columbia Ministry of Transportation and Infrastructure. He has over 25 years of experience working on transportation-related projects in both the public and private sectors. His responsibilities have included road safety and traffic engineering, developing road safety policy and standards, and road design. Joy has co-authored several publications in the field of road safety. He's an active member of numerous road safety committees in British Columbia and throughout Canada. And our second speaker is Mohammed Essa. He's a senior road safety engineer with the British Columbia Ministry of Transportation and Infrastructure. Previously, he worked as a traffic data analysis and graduate research assistant at the Bureau of Integrated Transportation Safety and Advanced Mobility at the University of British Columbia. He's also worked for several consultants as a road design engineer and transportation engineer. His professional experience includes road safety, traffic engineering, and road design. He received his bachelor's degree in civil engineering from Ain Sams University and his master's and PhD in transportation engineering from the University of British Columbia. He's authored or co-authored more than 18 publications in top-tier transportation engineering journals and research journals in several areas, such as road safety, collision prediction models, reliability analysis, traffic conflict techniques, surrogate safety measures, connected autonomous vehicles, traffic simulation, adaptive traffic signal control systems, and real-time traffic management and optimization. He's received several awards, including the Michael Van Erd Memorial Scholarship from the Canadian Institute of Transportation Engineers, the Esch Foundation Scholarship from the Transportation Association of Canada, and the 4-year doctoral fellowship from the University of British Columbia. He's also a registered professional engineer in British Columbia and a certified road safety professional. So with those introductions, I'm going to go ahead and turn it over to Joy and Mohammed to lead us through the work that you've been doing with high friction surface treatments for signalized intersections.
Thank you, Dave. It's a pleasure to be here today. I'm joining you from Victoria, British Columbia in Canada, which is the west coast of Canada, which is also the unceded territory of the Lekwungen-speaking people in the Songhees and Esquimalt nations, which I respectfully acknowledge. So I'm going to get on to our slide deck here, and hopefully that all goes well. Okay.
So are you seeing the full screen for the slides?
Yes,
yes.
I can see it. Perfect.
Yes, thank you so much.
Welcome.
So yes, yeah. So So we're going to talk about measuring highway safety and functional performance. Mostly, we're going to focus on the safety aspects of today's presentation, but I thought I talk a little bit about how we came about doing this project. So if you could move on to the next slide, please, Mohammed. If you can advance to the next slide, Mohammed. Thank you. So this is a quick agenda of what we're going to want to talk about today. I'm going to do a brief introduction in terms of what HFST is all about. I know that there's been a series of introductions to this topic and webinars. I know most of you are probably quite familiar with the topic, but for the benefit of everybody, I thought we'd just touch on some basic what HFST is about, and then right after that, we can jump right into our own project in British Columbia, particularly dealing with intersections and ramps. And then we're going to spend quite a bit of time in terms of safety effectiveness, how we measure safety and what some of the outcomes were. And then we're going to jump right into lessons learned. So just getting into the introductions, what is HFST? Well, essentially, it's a pavement treatment with exceptional skid resistance properties. Typically, depending on the existing pavement conditions that you have where you're applying, you can actually have in terms of upwards of 200% increase in your pavement surface, which you typically do not see in your traditional types of pavement that you have, such as the asphalt and Portland cement. Now, the way it's done is you would apply a polymer resin binder, which is typically about 1 to 2 millimeters thick, and then you would spray aggregate. So these are polyethylene abrasion resistant aggregate. Typically, we call for calcium oxide, and they tend to have a very high friction level of high frictions, and also they last for a long duration of time. I know that people have seen high friction surface treatments of applications lasting 5 to 7 to 12 years, depending where it's located and what sort of traffic it endures and what sort of weather it goes through. So it's a treatment which has exceptional skid resistance properties, basically essentially increasing the coefficient of friction. Go to the next slide, Mohammed. So HFST is typically used for safety treatments, where you have issues with friction demand, where you need to stop faster, or where you need people from going off the road. So road departure type of crashes would be a good location, which we typically see on horizontal curves. I know that FHW sort of has a recommendation in terms of where these things typically happen. So you say radius of 1,500 feet or less, which turns out to be about I think 450 or around 460 meter radius curves, and also for locations where you are having issues on grades, typically less over 10% grades, would be good locations. And also what we know that because it helps with the stopping distance, a good locations where we thought would be applicable are intersections where we are having issues, or where the pavement is actually not providing the kind of resistance friction that we would need for a vehicle to have to stop. So those are some of the typical applications of HFST that you would see. Moving on to the next one, Mohammed. So yeah, jumping right into our project in British Columbia. So which is you see where we're located, and on to the next, Mohammed, please. Thank you. So our project, I've attended there was a conference by TRB back a few years back about roadside safety, and that's where I was learning a lot about HFST. And so I brought it back to our ministry, and in 2018, we were noticing, around 2018, the Insurance Corporation of British Columbia, which is a private insurance body, came to us basically indicating that there's been a spike in motor vehicle insurance claims, and they wanted to partner up with us in terms of what they could do from a financial aspect of it. So we looked into it, and then most of the collisions were happening in the lower mainland, where we have the majority of the population. So that's where we were seeing a lot of collisions, and we have lots of intersections. The traffic volumes are really high, and a lot of collisions were actually happening at intersections, intersection approaches. So we said, well, HFST is probably a good intervention. And so we partnered up with them, and we started doing some analysis in terms of what are we really trying to achieve here. So we targeted rear end type of collisions at intersection approaches. So that was so we already knew what we wanted to address here. So we went with a countermeasure based approach to identify these locations where we were seeing overrepresentation of rear end collisions. So we did this provincial analysis of identifying all these locations and calculated the potential for collision reductions for the entire province. And we ranked them. And based on that, we were able to identify rank all the locations. So we had a budget to work with. So we had to be careful. Of course, these things also, in addition to scientific evaluations, there's a political aspect of it in terms of, if you're doing it all in one area, what about other areas? They'll never get this kind of treatment. So we were aware of that as well. So that was an important aspect of site selections. But where we were not able to get a good data to evaluate using the same methodology were the ramps, because our ramps are actually not coded very well by the police, so there was not really good indication of it. But the insurance company has a pretty good numbers in terms of collisions occurring at ramps. But we don't know exactly where ramps, but it's indicated as ramps, and we basically use some of their numbers to identify some of the interchange ramps to treat as well. So that's the site selection methodology we sort of went through, and at the end, I guess maybe we can move on to the next slide now. We were able to identify 15 signalized intersections approaches within the budget and 6 off-road ramps. All this happened in 2018, and then we started implementing HFST. So we were only able to get to one location in 2018 because it was starting to get late in the year. And most of the implementations happened in 2019. So because we don't have a very good collision data for the interchange ramps, well, we said that for our assessment, for our safety effectiveness assessment, we're just going to focus on signalized intersection approaches. And so from here on, the presentation is just going to focus on the signalized intersection. Next one. So yeah, so just an indication, just where some of the locations are, and so for most of you probably won't know where they are. But just wanted to mention that we actually identified not just by intersection approach. So there are locations where we did not put in HFST at both approaches or all 4 approaches. It would be maybe just one approach, and we focused on the through travel lanes, and so there none of the turn lanes were we did not focus. We did not apply HFST on the turn lanes. And typically, the length of the applications were between 150 meters and 250 meters. So depending on the intersections, and as the traffic volume changes throughout the day. So we could not sort of go with worst situations at one locations and have a really reduced number of sites. So we sort of tried to find a balance between the length and the number of intersection approaches we wanted to do. So that was our approach. And the other thing I should also mention that we went from the stop bar back. That's how we went. We didn't carry it through the intersection in most cases, partly because most of our intersections are I shouldn't say most, but many of these intersections where we did apply also have protected left turns. So although they were sort of kind of part of the equations in terms of determining locations in terms of 90-degree collisions at intersections and also left turn, our focus was mostly rear end. We can move on to the next slide. And so this is just another locations of highway transit. Some of the locations where we identified HFST would benefit from HFST. Can move on to the next one, and these are some of the locations on the island. So just an indication that most of our locations are actually in the metropolitan area where volume is significantly high, and also at times when the volumes goes down, the speed and through the intersections can be a little bit higher as well than posted. So this is just a summary of all the locations where we have applied HFST for signalized intersections. We just summarize it here in terms of highways and class and where they're located, and also the approaches and the implementation date, because this is kind of important for the next part of the presentation, because the Mohammed is going to talk about develop models and things like that. But we really wanted to make sure that we're applying the right kind of models and for the class of road and then be able to identify the treated approach versus the comparison of the reference approach for next part. So that's just a quick synopsis. I believe I think the next one we're starting from for safety analysis, but just a quick synopsis of how we got. Oh no, sorry, there's one more slide. That's right. Thank you. So yeah, so this is just a quick summary of all the locations, and I wanted to mention the installation specifications, very quickly, even though it's really, I think most of you probably know all about this by now. I had a really long discussions with FHWA, the vendors, and also contractors, and did a lot of literature research in terms of learning about HFST and the specifications. And I've learned a lot about through these discussions about how important it is to sort of touch on so many aspects of HFST. Starting from aggregate to the type of binder you need, the construction methodology. We really went with the truck-mounted automated applications of HFST, because that was one of the things I learned that is important in terms of the outcome, and all the other ones listed on this list, such as the conditions of weather and the quality assurance. And we also kind of paid quite a bit to get some friction testing done, which helped us in terms of ensuring that it was done right, because we did find a couple of locations with a lower friction number where they had to come back and fix it because they switched the aggregate because they were having hard time with the supply of the aggregate. So I think expensive, but I think that it was worth for us because this HFST application is the first one of this kind in Canada, I believe. And then it's the pilot for us, so it was important for us that we didn't set ourselves up for failure, but making sure that the pilot was given the attention it deserved. So we have quite a bit of detail on every one of the ones listed here in our spec, so if anyone later on is interested, we can share the detail of how detailed we went in terms of specifying these aggregates. Like I said, calcium bauxite, sure that was the case, and in terms of also post application, so which we'll talk about at the very end. But at this point, I guess we can move on to the next slide, Mohammed. Oh yeah, a quick.
Joy, we have a couple of questions that you might want to answer now. On the table, Joy was referring to what are the different class of roadways, freeways or just collector street?
Oh yeah, we can go back to that slide, Mohammed. Yes, good question. So these are all abbreviated. Basically, we're talking about undivided arterial, undivided 4 lanes. Yes. So this is the undivided 4 lanes. Most of them are arterial roadways, we call them here, and then we have some divided 4 lanes. And so the urban arterial undivided 4 lanes, that's the UA, U4, and the RA, D4 are rural arterial divided 4 lanes. So those are primarily that. Yeah. So these are multi-lane roadways in those 2 settings. I think that's what most of them are.
And then the second question is, how were the surface application limits based on?
Yeah, so good question. And so we looked at queues. So that was our first indicator, was how long are the queues, and then also we were sort of kind of paying attention in terms of when does people start to brake, the brake lights tend to come on. So that was sort of kind of our focus, and then some observations on site, and where people are coming to a quick stop. and that was, you know, we were not able to go all out on some intersections in terms of some of the intersections, you know, some at some during some time in the day they can get much longer than 200 meters, and we said, well, that's probably going quite far beyond. Do we get the benefit of it? Perhaps there is benefit for it, but we had a budget to work with, and we wanted to sort of kind of say, where can we find the balance point on that? And then the traffic volume has changed quite a bit since COVID as well. So that number has changed, and the queue lengths have changed since then as well. So it sort of kind of worked out in our favor in some ways. So that's how we determined, and we made a conscious decision of not carrying it through the intersection. Hopefully that answers the question.
All right, and then has there been any after studies conducted to evaluate the application?
Yeah, so there hasn't been any after study to evaluate the application. What we are, so the friction test was the one we did within a year. So that was done. What we're sort of kind of paying close attention in the sense that we know most of us that sort of drive through over most of this on a regular basis, and we're just keeping an eye on it. You know, because also the part of the funding also came from Insurance Corporation of British Columbia. They're sort of kind of interested in knowing how it's working out as well. Of course, we're going to talk about the safety evaluation part of it, but in terms of actual physical, they are actually holding up quite well. There's been some, I shouldn't say delamination, it's actually a failure in the pavement itself, because the last couple of years we've had a pretty severe winter in terms of the cold snap that we had this Arctic cold front come in. Not snow. We don't get a lot of snow in the Lower Mainland. We get maybe 2 or 3 times, but not sustained snow. The cold, and then also because we get lots of rain, and the cold has actually led to failure in the pavement itself. So there's a couple of places on the ramp, a couple of ramps where we saw some spalling of the pavement. So we did some localized fixes there. But this year I heard that there's one of the locations have actually pavement failing in the travel lane, and then they could do some patchwork, but I think the indication I got from the pavement crew is that the rest of them will also fail. It's not the HFST that's failing, but it is the underlying pavement that's failing because of the cold that we went through. So because of that, they'll mostly remove most of it and pave it over.
Thank you, Joy.
So yeah, so this is some of the equipment that we use is actually from our own project. Well, we wanted to just show what the truck mounted application unit looks like, and there's a vacuum truck, and yeah, so it went overall. The project went really well, and we're quite happy with the outcome of it. I know that here in the north, we had one of our challenges was actually getting a contractor out here. We had only one bidder that came down from the US, and because of that, I think the work in Canada is probably relatively a lot more expensive compared to the one that work that's you get being done in South in the US. Partly because of I guess the distance, and because some of the work we had to do was shortly after COVID started for some of the work they had to come back to, so that's what kind of added to the cost. So there's a fact, but overall we're quite happy with the outcome of this work. So we'll just move on to the very next slide. If there are no questions at the time, and which is this. So the safety effectiveness evaluation is the main topic of today's presentation. So Mohammed is going to walk us through the safety evaluation part here. Thanks, Mohammed.
All right. All right. Thank you, Joy. So are you able to hear me now, or can you see my screen?
Yes, we can hear you well.
Okay, perfect. Thank you, Joy. Thanks, Rita, Dave, and Adam for organizing this webinar. And thank you, everybody, for attending. My name is Mohammed Issa. I'm a road safety engineer with the British Columbia Ministry of Transportation and Infrastructure. Before starting, I would like to begin by acknowledging that I am on the traditional and unceded territory of Musqueam, Squamish, and Tsleil-Waututh First Nations. I will talk about the safety effectiveness part. In this evaluation, we're trying to estimate the safety effectiveness of the HFST. So basically, we evaluated that effectiveness using two techniques. The first one is using surrogate safety measures or traffic conflicts. And the second one is the traditional before and after safety analysis using historical collision data. So in the next slides, I will go through each of these techniques. So the first one is the traffic conflicts, in which we used video analysis or video analytics to do before and after analysis, and also we did cross-sectional analysis. So the objective of the traffic conflict study was to provide an early evidence of the safety effectiveness of the implemented HFST pilots. So the University of British Columbia completed the safety assessment study in 2021. And the study actually evaluated the safety performance of HFST by adapting automated video-based traffic conflict analysis using a total of 147 hours of video data collected at 2 intersections from the treated sites using 4 cameras before and after the HFST implementation. They analyzed traffic videos using deep learning video detection and tracking techniques to extract vehicle trajectories and identify rear-end traffic conflicts or near misses. In the traffic conflict analysis, they used the time to collision as the traffic conflict indicator. So from the treated locations, 2 intersections were selected for the analysis. So the first one, as shown in this slide, is the intersection of Highway 17 and Seaward Road on Vancouver Island. And the second one is Highway 7 and Light Street in Maple Ridge in the Lower Mainland. So at each of these intersections, the HFST was applied only at one approach, which is the treatment side or the treated approach. And the opposite approach along the highway was used as a comparison site to account for any unrelated factors that may affect the number of collisions. Again, a total of 147 hours of video data were analyzed using the cameras, like 2 cameras at each intersection, or 1 camera per approach. So in this slide, there's a summary. This is a summary of the traffic conflict results. So we have, they used 2 methods of safety effectiveness assessment. And the reason of that was about the data availability. So at intersection 1 or intersection A, they have before and after data. That's why they conducted before and after safety evaluation, while at intersection B, the only available data was after the HFST implementation. So they used the cross-sectional analysis in which they compare a treated approach with non-treated approach to see the reduction in the traffic conflicts. So as you can see here, the estimated treatment effect or the estimated reduction in the number of rear-end conflicts is from 36% to 38%, and it's statistically significant at 95% confidence level. So that shows like a significant improvement in terms of the number of rear-end conflicts at both intersections. In addition to the traffic conflict analysis, in 2022, we carried out an evaluation of the HFST safety effectiveness based on historical collision data. We used a couple of methodologies for the before and after safety evaluation. The first one is the traditional one, the empirical based methodology that's recommended by the Highway Safety Manual. And the second one is the fall-based analysis or fall-based method that's recommended by the recent research. So in next slides, we will go through each of them and showing the results. Before talking about the methodology, we just talk about the safety evaluation using historical collision data. So the objective of this part is to undertake a before and after safety effectiveness evaluation of the HFST applied to specific approaches at several signalized intersections in British Columbia. The before and after evaluation accounts for traffic exposure as well as various confounding factors, including history, maturation, and the regression to the mean bias. And the effect of HFST on safety was investigated by considering serious collisions and rear-end serious collisions, because HFST targets rear-end collisions as well, and also collisions that occurred in wet road surface conditions. This map here shows the treatment and control sites. So for the safety analysis, we selected a group of treatment sites, which are the sites where the HFST was implemented. And these sites are 15 signalized intersections approaches located on Highway 7, 10, and 17. We also selected control sites, which are non-treated sites to be used in the before and after analysis to control for the time trend effects, including the confounding factors of history and maturation. So the proximity to treatment sites was the main criteria when selecting control sites. So these sites are intersection approaches with similar traffic and environmental conditions as those of the treated sites. We have a total of 90 control sites for the analysis along Highway 7, like 35 sites, Highway 10, 32 sites, and Highway 17, 23 sites, as shown in this table. So we have a total of 90 control sites and 15 treatment sites. In terms of the data we used for the analysis, collision data for the treatment and control sites was obtained from the Ministry Collision Information System for the years 2014 to 2021, which represents periods before and after the HFST implementation. So the collision data for the Ministry Collision Information System comes via ICBC, which is the Insurance Corporation of British Columbia, from the MV6020 form, which is the BC Motor Vehicle Traffic Accident Police Investigation Report. So all of these collisions are police attended. And collisions are typically classified by severity into fatal collisions and injury collisions and property damage only collisions. So in the analysis, we only considered serious collisions, which is fatal and injury collisions, because they are comprehensive and deemed reliable for safety evaluation. On the other hand, the PDO collisions or property damage only collision are unreliable as they suffer significant underreporting. And also it's worth noting that in 2019, the British Columbia changed the threshold or the damage threshold to the PDO collision to be attended by police from 10,000 to from 1,000 to 10,000. So this is a significant change. So this is one of the main reasons why we excluded the property damage only collisions, and we only focused on serious collisions with fatal and which are fatal and injury collisions. Another thing here to mention is the target collisions. So since the HFST typically targets the rear end collisions at signalized intersections and also collisions in wet road surface conditions, so information about these categories of collisions were also extracted for both the before and after periods. In addition to collision data, the highway classification and the traffic exposure of each of the analyzed approaches were obtained from the collision information system. So we have traffic exposure, which is the annual average daily traffic entering the approach over 8 years, 2014 to 2021. So we got this data for before and after and for control and treatment sites. Sorry. So to provide a quick summary of the data we used, so we have a before period of 4 to 5 years and the after period of 2 to 3 years. So based on the implementation or the intervention year. So we have the HFST was implemented in 2018 for some sites and 2019 for other sites. The total number of collisions, we have about 1,038 fatal and injury collisions for all locations like treatment and control sites, of which we have 391 rear end and 329 in wet conditions. In terms of the annual average day traffic for treatment and control sites, the annual average day traffic ranges from 5,700 to 49,500 vehicles per day. In terms of highway class, as Joy mentioned, it was like rural divided 4-lane, urban divided 4-lane, urban undivided 4-lane, and all of them are arterial or expressway highways.
Mohammed, we have a question.
Sure.
Is there an attempt to develop any CRF or CMF for the application of HFST on wet and dry pavement? And if so, how many sites are you considering for that task?
Okay, so in terms of that's a very good question actually. In terms of the CMF, we didn't find like a CMF for signalized intersection or HFST at signalized intersections, but based in our analysis, we have a reduction. We have a significant reduction, as we will see later in the presentation. But the providing like CMF, of course, the larger the sample size, the better the more reliable the results. Here we used like 15 sites. Based on the highway safety manual, the recommended number of sites is like 10 to 20 treated sites, and also the recommended number of years before and after was about like 3 to 5 years. So we can use our data, but we can expand more. We can wait more for additional data for the after period. But again, we consider the statistical significance of the results. So the highway safety manual states that like 3 to 5 years before and 3 to 5 years after, and we can use shorter period, but the statistical significance is less likely. So that's why we can. It's the main condition here is the statistical significance. So I mean, we can our results are we are planning to publish our results, and also this can be expanded like when we have more sites and more data for the after period, and then we can do we can like publish something like collision modification factor. And also the other thing is the jurisdiction. So this like these results or this analysis is based on the only one jurisdiction, which is like British Columbia, and we have like Lower Mainland and Vancouver Island. So so we don't know the performance if we have like other locations with more severe winter conditions or something like that. So we don't know exactly what will be the effect. But again, this will be one of the contributing results toward achieving a reliable collision modification factor for the HFST. Does this answer your question?
I
Yes,
think
I
it,
believe you can move on. Yep.
Yeah, thank you. So now we move on to the next slide, which is showing the methodology to be used. So we use empirical base. So the main reason we use two methods is to verify the results. So we use two different methods. So the first one, the empirical base, which is the method recommended by the Highway Safety Manual, Chapter 9. There are three methods to evaluate that. This is the first one, using the empirical base technique. And the other method is the full base analysis, which is recently advocated by researchers for the before and after safety evaluation. It's despite its complicated computations, it's a powerful method with several advantages. So we can see that. But the main reason we use two methods is to verify the results and to account for any unobserved heterogeneity across sites or variances across sites, as we'll see in the full base method. So I'll start with the empirical base one. So the empirical base method, as much of you know, as much of you know, this is the traditional method by the Highway Safety Manual. So in which we employ a collision prediction model. We have a comparison or control sites to get the calibration factors. And also we have the empirical base refinement technique for the before and after safety evaluation to account for the regression to the mean bias. And the main question here is to know that what would the safety performance be had no HFST been implemented. So this method is described in detail in the Highway Safety Manual. I will go through quickly through the main steps we applied for the before and after safety evaluation. So first, this is the collision prediction model. We use the traditional model form in which we have the traffic volume or the average, the annual average daily traffic as the main explanatory variable. And then we developed model, and as we said, we have three categories of the collisions. So we have serious collisions, we also have serious rear-end collisions, and also we have serious collisions in wet conditions. So we developed the collision prediction model for each category of these collisions, and we used like a random intercept to account for the highway class, because we have different classes for the highways. And also we check the model fit, and all of these models showed a good fit with the significant coefficient and significant chi-squared at 95% confidence level. The next step in the empirical base method is to apply the empirical base refinement, in which we combine the observed and predicted collisions, as you know, to get the true mean or the expected number of collisions for each site. And this is actually what accounts for the regression to the mean bias. Also, we corrected for traffic volumes after HFST. So we use this equation to correct for the differences in traffic volumes for before and after. And lastly, we estimated the odds ratio and the treatment effect for the treated sites and for the HFST implementation. So I will go quickly through the full base method. I will not go. I'm not going into details and mathematical details about the full base techniques, but I'll just clarify, like highlight some points about that. Like although the empirical base is the most common method used for before and after evaluation, the full base method has been recently advocated as a powerful methodology for analyzing road safety and investigating the effectiveness of safety countermeasures. Based on research, like there are several advantages for the full base method. Like the empirical base, the full base method accounts for the regression to the mean bias and other confounding factors in terms of history and maturation. And also it accounts for all uncertainty in the data, including the model parameter. And the most important part here, the fold-based method account for the unobserved heterogeneity across sites. So if we have any latent variables or differences unobserved across sites, so this method will account for that. There are also some advantages, other advantages for the fold-based method, such as the flexibility in selecting the statistical distributions of the predicted collisions. So we can use Poisson gamma, Poisson log normal. So we have flexibility in selecting the distribution that best fit the collision data. Again, the main question is, what would the safety performance be had no HFST been implemented? In this diagram, we just simplify the process. So we have, instead of having different steps or multiple steps in the empirical based method, here in the fold based method, we combine everything in one model. The method integrates the estimation of the collision prediction models and the treatment and control sites and reference group before and after data, traffic volume, all of them in one model and one step. This is just an example of the models we use. We can use different forms of the models, but based on the recent research, we use the Poisson log normal intervention model with random intercept. And here we have, I will not go through the mathematical symbols, but just to let you know that we have in this model, there's like for each site, we have whether that site is like a treatment or control. For each data point we have for every year, we have the number of collisions every year, and we consider the time trend and the time trend effects. And also we consider the, like all of them, treatment, control, before, after, traffic volumes, everything in just one model. And then we use the statistical software WinBugs to do the computation and check the conversions of the model, and then we estimate the fit or the conversions of the model parameters and the statistical significance of the results. Here is the most important slide, which is the safety evaluation results. So in this table, you can see like there's like a yellow part, which is the empirical based method, and we have the blue part, which is the fold based method. So as you can see here, for each of them, we have 3 categories based on the collision type. So we have serious collision, serious rear end collisions, and serious collisions in wet conditions. And here you can see the reduction, the interval of the reduction, and it shows that we have like significant reduction in the estimated number of collisions. So we have, for serious collisions, we have an estimated reduction of about 51%. For serious rear end collisions, we have an estimated reduction ranging from 56% to 58%. And also for serious collisions in wet conditions, we have a reduction of 63% to 65%. And all of these reductions, like they are significant within the 95% confidence interval, based on both methods. So as you can see, the empirical based method and the fold based method almost give like similar results or very, very close results. So which is like one of the reasons why we use 2 methods, just make sure that our analysis is reliable and we have a significant reduction in that. And this is the last slide here for me. And now back to Joy for the installation and lessons learned. So it's to you, Joy. Thank you.
Thanks, Mohammed.
Joy, we do have another question.
Sure.
Could you discuss friction requirements in the specification, the threshold number, measurement method, and at the time, and the time when the acceptance was performed?
Right. I think that our requirement for the friction test was within 60 days after installation. And I think the number that we used was 72. The append, I guess, 40R, then you of course have to correct it to the various speed, I believe, and you got to do that. And I think 72 was the requirements for our, and I think the field dynamic friction, I guess for 20 kilometers per hour was, I believe, 0.9 as a minimum. And I think we went with all the test methods was in the ASTM, or whatever was described. So much of this information has actually come from in discussion with FHW from that time, at the time when we were looking at this information. But I think also we went with the profile depth of 1 millimeter as a minimum for that. I'm not sure if that answers your questions. I'm just going off the memory here, but I can give you that detail if you're interested. But as far as I know, that a lot of that information I was able to gather from the experience in United States and in discussion at HWA.
Yeah, I think you can go ahead and if we'd like to hear the lessons learned as
Oh,
we
yeah.
finish up here.
Yeah, I know we're sort of kind of running a little bit over time for the presentation. So Mohammed, if you want to just forward to the next slide, that'd be great. Thank you. Yeah, so this is just a from our experience in terms of lessons learned. There's quite a number of lessons we learned from this HFST application project, and I think it's really important that to sort of kind of go with quality materials in terms of both binders and aggregate, and then employing the best construction practices instead of addressing the issues later on. We specified an automated equipment, and although it's quite expensive, and we didn't have any local contractor, as I mentioned before, we had to go get one that bid for the job came from the south, and it was quite expensive, especially for us here. Important to walk through the site in advance, looking for areas of weakness, rutting, any utilities there, and how to deal with that if we've considered hazardous material and things like that. One of the things we budgeted for was friction, but we didn't really think how expensive it was going to be, especially in Canada. There was an outfit that came out from United States through which was brought in through one of the contractors who bid for the job. So that's you have to account for that in your budget, because that, especially for folks, if anyone's listening here in Canada, that can be quite an expensive item. The gravel removal, excessive gravel removal, we noticed that there was actually quite a bit of shedding that happens after. Then I think that we had to look. One of the things we learned was the frequency of vacuum sweep was important. We were thinking that maybe 18 hours after 2072 and a week later, especially if these routes are also used quite frequently by motorcyclists and cyclists. Oh yeah, loose gravel sign, one of those things that you don't think about ahead of time, but yeah, that was I thought was key in those locations where we have our cyclists and motorcyclists. Where to store hazardous material and thinking ahead of time, it's actually so important as well, and where you store your aggregate, and also developing some key messages ahead of time. Because people were quite curious in terms of what was happening, and they were quite, so developing all this messaging, working with your communication folks and getting that information out. So yeah, those are some just quick lessons learned. I know we're running a bit out of time here, but I think that's we can move on to the next slide, and that's probably the end of the presentation. And just we do want to acknowledge our Insurance Corporation of British Columbia, who actually partnered with us in terms of finding commitment and to deliver this project. And I think that sort of summarizes and finishes up our presentation. So thank you.
All right. Well, thank you very much, Joy and Mohammed. Excellent presentation. Very interesting work. And I know there's a lot of interest in that. I did want to ask one question. I think we had a few other questions pop up, but one of the reasons for the interest in high friction at intersection approaches is pedestrian safety too. So one question I had was, did you have any pedestrian related crashes at any of these intersection locations? Did you evaluate those, and did you see any reductions after you applied high friction?
Yeah, so our focus was not pedestrians, and none of these intersections that were selected were actually known for pedestrians safety. Typically we would see if there's some kind of encroachment into the pedestrian area. at these locations. That was not really the issue that was brought up to us. It's mostly rear end. And also because we operate mostly our jurisdiction is out of urban areas. We have some urban roads going through some urban centers, but many of our roads are, we operate highways and freeways. So our environment is a bit different, but at this location still there's quite a bit of traffic, but pedestrian was not identified as pedestrians was not identified as an issue, and hence we actually did not evaluate it.
Okay, great, thank you. There's a couple of questions related to quality control, quality assurance, and there was also a question about project specifications or special provisions, if those can be provided. And we'll chat with you after the webinar if it'd be possible to provide a PDF or something of the specs that were used on that project, which I assume would include some QC/QA requirements for the project.
Yes, we can do that.
Okay.
You just wanted to mention quickly that, since we did this work, there's been a lot of interest from other municipalities, and I think the only thing that was their concerns is because they like to do their areas, smaller areas, and they don't have a big project to go with, and so they're looking in terms of how that's going to affect their budget, because especially we're telling them that they're doing, because we have our experience with we've had heat resistant treatment in the past did that very well, so there's a bit of resistance to this, but then they also see the difference in price. So I think there's the challenge is trying to be able to convince the folks who have used similar type of product, I wouldn't say product, but application, but they had bad experience with it. So we were quite adamant that with this particular project that they'd be actually machine applied, and then that we follow very strict specifications. I think that was the key, was the specification, and that we follow the specifications, and we want to give it a fair trial. Okay. And that's the message I'm sort of sharing with our municipalities who are showing interest as well.
Okay. Well, thank you very much. It looks like we're about out of time. Adam, any final words before we close down the webinar?
I just want to thank Joy and Mohammed for their presentation today. Definitely very beneficial, very informative. And, I think there's definitely a push to start seeing high friction surface treatment at more signalized intersection approaches or stop controlled approaches to intersections. So, hopefully this motivated some folks on the webinar to start moving forward with that. So again, thank you for your time today. I want to thank everybody for joining into the webinar today. We appreciate it. And if you have any feedback or any additional webinar topics that you'd like to see related to high friction, please email Rita, and she will get that information over to the committee.
All right, guys. I just want to let everybody know I did put the link in the chat to the ATSA HFST webinars. This webinar was also recorded and will be uploaded within the next few days.
Great.
Good.
Thank you all. Thank
you,
Joy and Mohammed.
Thanks so much.
Yeah,
And thank you all for
everybody.
joining us.
Yeah, thank you so much.
Thank you.
Thank you. Take care.